This is Hanover Street in Boston's North End. Paul Revere lived here and hung his 2 lanterns in Old North Church in the early days of the American Revolution. But even before the Revolution, in the early 1700s, an enslaved man called Onesimus lived here with a Puritan minister named Cotton Mather. Together, they helped introduce an early kind of vaccination to the city of Boston. Onesimus explained to Mather that when he was growing up in Africa, he'd been deliberately exposed to smallpox through a cut on his arm, and that it gave him protection. The idea was that a small amount of the virus, transferred from someone who was infected, could confer immunity. Mather verified Onesimus' story with other enslaved people, and he helped to introduce the practice to Boston. This ended up being wildly controversial, and even Ben Franklin was talking smack. Some people were hesitant to trust a procedure that was developed by and for enslaved people, because of course they were. Others called it unnatural and said it was against their religion. Someone even tossed a grenade through Mather's window, which fortunately didn't explode, but it did come with a very rude note that said, "I'll inoculate you with this." True story. But in 1721, a smallpox epidemic came for Boston, and one local doctor, Zabadiel Boylston, supported Mather and knew that it was time to test Onesimus' theory. He began by inoculating his son and enslaved workers, and eventually Bostonians started to accept the novel medical procedure. Of the 242 people that he inoculated, only 2% died, compared to the 14% of Boston's population who had not been inoculated. And this is what established the foundation for modern vaccines. We don't know much about Onesimus, and he wasn't viewed as an important figure at the time. There's really only one monument to his contributions to science. It's this sculpture in the neighborhood where he lived, just a few steps away from the Paul Revere house. 7 years after Paul Revere's Midnight Ride and 1 year before the Revolution was over, Harvard opened up its medical school. And then in 1811, 2 of its professors founded Mass General Hospital. In 1846, if you were a doctor in training, you might have been sitting in these seats watching the very first surgery being performed using anesthesia by John Collins Warren. At the time, they used ether. Warren removed a tumor from the patient's neck, and he apparently didn't feel any pain at all. And when he woke up, he just said that it felt like his neck had been scratched. This isn't him. The patient went on to live for another 9 years. It was fine. This ended up setting the stage for widespread anesthetic use in modern medicine. Massachusetts doctors did the first successful organ transplant and the first successful reattachment of a limb. It had been severed when a 12-year-old kid was attempting to hitch a ride on a train. Yikes. Meanwhile, a doctor at the Children's Hospital pioneered chemotherapy, helping patients to survive leukemia, which was almost always fatal at that time. And today, that doctor, Sidney Farber, has a cancer center named after him. Just like some Bostonians were skeptical about the use of inoculation in the 1700s, in the 1970s, they worried about research involving recombinant DNA that was being proposed at MIT and at Harvard, where scientists were exploring the idea of manipulating the genetic information inside living organisms. Critics were concerned about the unknown dangers of modifying DNA and the potential introduction of new microorganisms that could harm public health. There were huge debates in Cambridge, and some of them actually right here at City Hall. So they had to come up with a set of rules and guidelines so that research could even happen.
I have made references to Frankenstein over the past week, and some people think this is all a big joke. That was my way of describing what happens when genes are put together in a new way. This is a deadly serious matter. If worse comes to worse, we could have a major disaster on our hands.
Because of those rules, Cambridge became a safe place for biotechnology research to actually get to happen. Some of the earliest startups in that field, like Biogen and the Genetics Institute, they put their roots down here. In the 90s, the Whitehead Institute was a major contributor to the Human Genome Project, which sought to sequence all of the genetic information in a person's body. Next door to the Whitehead, here at the Broad Institute, researchers are pioneering new ways of editing our genomes and exploring the relationship between our DNA and diseases like schizophrenia and cancer and diabetes. These days, this city is the global hub for life sciences, with hundreds of companies, big and small, working on new drugs, new medical devices, and gene therapies that are helping people live longer, healthier lives. It's the kind of place where they make statues of biotech entrepreneurs and where you might just meet a Nobel Prize winner while walking down the street.
Can you tell me a little bit about the research that you did that earned you your Nobel Prize?
The Nobel Prize is for discovering how to work out DNA sequence, the order of chemical groups along the DNA. And in 1970, it was essentially impossible to do.
Yeah.
We deciphered one of the first DNA sequences ever done, 24 units along the DNA, and it took us 2 years. And then in 1975, almost by accident, doing a totally different experiment, I discovered a very simple way of displaying DNA sequence. And so suddenly one, without the way of displaying the sequence, one could work out hundreds of bases in an afternoon. And we published those methods, gave them away actually, and everybody began to sequence DNA. And that's the time we got the Nobel Prize, because everybody realized that the technology was sweeping around the world.
What do you think the next innovation is going to be in genetics and genomics?
The interesting innovations you can't predict. Our biotechnology exists in terms of current knowledge. And most of that effort is simply how do we apply the current knowledge, as what we call applied science. The novel changes all come out of basic research, and they discover something new that was unexpected.
Subscribe to the Innovation Trails YouTube channel to catch all the videos in this series.